we'll move to the next topic, and this topic is called as this is the equilibrium. All right. Now, this is a specific stage of a system under the uh, of a system where multiple forces are acting on the system, and there is no resultant. All the forces match to each other such a way that there is no moment, there is no movement, no net force. Okay, so if a okay, if the resultant, let's write it. Okay, if the resultant of a force system is 0 and total moment of system is also 0, right? Then the system is said to be in equilibrium. Then system said to be in equilibrium. Right. So the idea is that we take the sum of the forces that results in 0. If you try to find the resultant of the force system, that is going to be equal to 0. That is the very first characteristic of this kind of system. Okay. Whenever the overall resultant is equal to 0, we can say that the system is under equilibrium. Okay, point number 1. Then, if I try to find the total moment, right, summation of m at any point on the system, that is also coming to be equal to 0. If the two conditions are satisfied, then we can say that the force system is under equilibrium. Okay. So first, let us try to solve some of the problems on concurrent coplanar, where the summation m is not considered. Okay, and later on we can also try solving the problems associated with the equilibrium of coplanar non-concurrent force system. Okay, so what are the conditions? Right, the resultant is equal to 0. So resultant equal to 0. This actually implies that the summation of fx is 0 and sum of fy is also equal to 0. Right? This is the only condition that we need to check whenever we are trying to solve the problems of coplanar and concurrent. Coplanar concurrent force system. At the same time, if my intention is to solve the problems based on the coplanar non-concurrent, then in addition to this, I also have to apply the summation of moments of all the forces about any point A is also should be equal to 0. So this is going to come into picture for the coplanar non-concurrent force systems. All right, let's solve some problems. The question is find the force brings equilibrium. Find the force that brings equilibrium in the following system. Okay, now we'll give a system and we need to find the force which actually brings the equilibrium. So first we'll solve the problems associated with the coplanar concurrent force system. Second force, force number 3, and force number 4. So this is 175.95 Newton at an angle 39 degrees. Okay, this is 67.77 at an angle of 55 degrees. This is the force which is 48 Newton at an angle. Oh, sorry, this is 148 Newton at an angle 16 degrees. Right? And the last one is 97.66 Newton at an angle of 85.5 degrees. Okay. So, in order to solve this particular question, so let us assume the x and y first. Okay, so these are the x and y axis. Now, the solution begins with assuming the force required. Okay, assuming the force required in the sense you can mark anywhere. Let me assume that there is a force which brings equilibrium. Let me assume in this. This is the force which is the unknown force. I'll say F and an angle theta. Okay, this is the theta. Because when I assume a force, I have to say vector quantity. So I have to specify what is the angle. All right. So what is the angle I need to assume? Right. Let me assume an angle theta. I don't know that. Now my question is find that force F, which is the magnitude, and find that angle theta such a way that this whole system is under the equilibrium. Okay. Now for this whole system, what is the condition for equilibrium? The condition is nothing but simply summation of Fx should be equated to 0. Also summation of Fy should be equated to 0. All right, so I have to first write the equation corresponding to summation of Fx equal to 0. So you write the normal equation where you find the x component of every force and you equate that force to 0. That is my first requirement. All right, so let's do that. Starting from the first force, 175.95 because 39 degrees. Right? Then the second option is minus 67.77 into sine 55. Then once again minus 143 cos 16. Okay, that's the force F. Sorry, I missed F. F also should be added. So F is assumed to be plus F cos theta. All right, and 148 is over. Then we'll write plus 97.66 sine 85.5 equate this to 0. All right, so what I have to do, I have to simplify this whole equation and I should write what is f cos theta. F cos theta equal to something you will get that you need to calculate first. So this is equal to f cos theta is equal to minus 36.31. All right, let's hold on to this. This is say first equation number 1, right? Now do the same thing, but you write for fy and equate it to 0. So starting from the first one, that is 175.95 sine 39. Then I'll write the f value here. So plus f sine theta, right? Then plus 67.77. This is sine. No, is it sine? Sorry, cos. Okay, so 67.77 into cos 55 degrees, then minus 148 sine 16, and the last term is minus 97.66 cos 85.5. Equate this to 0. So when you equate this to 0, I retain the term f sine theta on one side, equate, right, and find out after simplification what is this value. So when we solve this, we are going to get minus 101.14. So call this as equation number 2. Now we have two equations and there are two unknowns, right? F and theta. So what if I try to divide 2 by 1, right? Let's try to do this. So equation number 2 divided by equation number 1 gives you the f sine theta, equation 2 by f cos theta, equals to, on the right hand side, minus 101.14 divided by minus of 36.31. So you see f cancels. What is sine theta by cos theta? That is equal to tan theta. So tan theta equal to minus minus cancels. Divide 101.14 by 36.31. So this comes to be 2.78. Now, so this means if you want to find theta, this is tan inverse of 2.78. 70.21 degrees is the answer. Okay, we found the theta value now. So now you can put this theta anywhere so that you can find what is the f. Okay, magnitude of f you can actually calculate, right? So f, if you want to find, right, f is equal to, right, use the equation number 1, that is minus 36.31 divided by the cos of 70.21. So anyway, our intention is to take the magnitude, so it cannot be negative, right? You simply take a magnitude, right? Andre idu simplify ಮಾಡಿದಾಗ negative ಬಂದ್ರೆ take a positive. Okay, magnitude, only magnitude. So you can do 36.31 divided by cos of 70.21. That's all. Okay, you get a positive answer. Okay, 107.24 is the magnitude, so that is in newtons. Okay, so equilibrium is a straightforward concept where resultant is 0. Okay, let's solve another problem of similar type. This is 211 Newton at an angle this is 13 degrees, 1 3. Okay. So the question is find that resultant, find the force, find the unknown force, right? That brings equilibrium in this particular system. Magnitude of F comes to be equal to F is equal to 120.48. Okay, Newton, and theta equals to 16 16.17. Okay, next question. Find theta such that the resultant of the following system has no y component. .45 Newton, 35 degrees, (90 Newton) theta, (65.5 Newton), 45 degrees, (55 Newton), 20 degrees, (120 Newton), 65 degrees. So the data is given, all the forces are given, one of the angle is not given, and we have to find out what is that angle for the given condition. So when we solve this, we get value of theta equals to 13.88 degrees. Okay. So how do you solve? You have to make that Fy is equal to 0, right? Summation of Fy equal to 0. Okay. Now let's move on to the next part of the question, where we will consider coplanar non-concurrent forces. So the question is the reactions find the reactions at the support. So this is reaction at A. This is the reaction at B. Now, so we have a force 60 Newton at 45 degrees, 90 Newton perfectly downwards, 85 Newtons at 70 degrees, 40 Newton, 60 degrees. Okay, so this distance is given as 2 meters. This is 3 meters, 6 meters, 1.5 meters. This is 3.5 meters. Right? So find the reactions that supports, in the sense there are 4 systems and you are supporting this system by RA and RB. This is something like our previous problem where we had a single force which, right, brought the equilibrium for that given system. Okay, but now you see we have 2 different forces which bring the equilibrium into this force system. So how much, what is the value of RA and RB, we have to find. Okay, you can see that they're perpendicular, so no theta will come into picture. Okay, so my first condition is always the summation of fx equal to 0. Right, writing that, start from any one side, you can go with all the way through all the forces. So the 60 Newton is positive, so that means 60 cos 45. Then RA will not come, 90 Newton will not come. Next one, that is 85, so plus 85 cos 70, it is positive. Then minus 40 cos 60. Only these are the horizontal components, right? Just a second. 80 cos 3. This one fx equal to 0. Which component is 0? 60 cos 45. 85 cos 70. Cos 60 equals to, I cannot make it equal to 0, right? Let me check, question check. So the difference lies here. Since there is no unknown along x-axis, I cannot solve using the fx equal to 0. Okay, so my solution is directly start with the fy, because unknowns are along completely along y-axis. There is no component which is along x-axis. Both RA and RB along y-axis. So apply this summation fy equal to 0. Okay, so that means first term 60 sine 45. Then RA is going upwards, so plus RA. Then 90 is coming downwards, minus 85 is coming downwards, minus 85 sine 7. RB is going upwards, plus RB. And 40 Newton is also going upwards, so plus 40 sine 60 equal to 0. So unknowns kept one side, that means RA plus RB equals to, right, what value you can solve by using the equation 60 sine 45 minus 85 sine 70 plus 40 sine 60. You can calculate and bring the answer. So RA plus RB is equal to 92.8. This is equation number 1. Now anyway, I cannot apply summation fx equal to 0 because no unknowns along the horizontal component. Right. So my other option is that since this problem is basically on, I can see that this whole system is a non-concurrent coplanar. For non-concurrent coplanar, if you look at the rule, under equilibrium, I have to apply summation m is equal to 0. Okay, so let us do that. Take any one point and apply the values of, take the moments and equate it to 0 about that point. So I will try to find the moment about a point, say 8. Okay, so summation of the moments about the point A equal to 0. This is true for any system under equilibrium. Okay, at any point you can take any random point. So I try to take it over there, because if I take around at a point A, RA cancels, because RA passes through A, so moment becomes 0. I can find one of the other answer, RB I can find. So let's try. So there is a 60 Newton force. The 60 Newton force, right, acting upwards, which is with respect to A, it is clockwise. So it is minus, I have to write a vertical component. So that is 60 sine 45 into the distance. Distance is 2 meters from A. Right. That's the first thing. Then, if you look at the force 90 Newton, that is perpendicularly acting at that. So directly distance is available and it is clockwise, so negative, minus, this is 90 into 3. Okay, then the 85 Newton makes an angle 70. Horizontal component passes through A, vertical component only I can take. So this is minus 85. This is sine 70 into the distance, that is 3 plus 6, 9 meters. All right, then RB, you can see RB is actually acting upwards. So with respect to A, the force RB rotates anti-clockwise, so positive. So plus RB into the distance, 6 plus 9 plus 1.5, that is 10.5, right? Then there is another force. The force is equal to 40 Newton acting upwards, so positive. So this is plus 40, right, into the sine of 60 degree. Distance is previous number plus 3.5, 10.5, 11, 12, 13 and 14. Okay, so this is 40. So should be equal to 0, right? So use this equation and find what is 10.5 times RB, or you can actually calculate directly RB, right? Whatever you get, divide that by 10.5 so that you can calculate RB. So this implies RB equals to, so what is RB? RB equal to 56.07 Newton. All right, we got RB. So use this, call this is equation 2, put 2 in 1 to calculate RB. Okay, so RA is equal to 90, much? I think something around 90. Okay, so calculate the value of RA. RA is equal to 92.8 minus 56.07. Okay, so that is 36.73 Newton. Okay, next question. Okay, this is the next question. Solve using the similar method. Find the force F which brings equilibrium following system. Ten Newton, 15 Newton, 10.5 degrees, F theta, 65 Newton, 38 degrees, $85 Newton at an angle 75 degrees. This is 10 Newton. This is 15 Newton. Okay. So after solving, we get the answer. That is F equals to theta. Okay. We want both. Okay. Theta is equal to 35.37 degrees. All right. Yes. We need F as well as theta. F 84.56 newtons.